To introduce David, who's you might know is the maintainer of ARA, which is the Ansible, the code's Ansible, so we've got some nice stickers here. So David's going to talk about how you can use AI in a really good way to help you with your automation. So
thank you, good.
Over to you. Thank you.
Yeah, let's get started. Thank you for having me. It's great to be here. It's such a great time to be at Conflict Management Camp. I'm on 4th day of conference with FOSDEM, but I still have some energy left, so let's get started. Quick intros. So I'm David Moreau-Simard. You can find me on Mastodon, and also I'm around the Matrix. Nowadays, I'm an architect at OVH Cloud, doing OpenStack cloud things. It's great fun. I come from a background for the past 20 years doing sysadmin, DevOps, SRE kind of things, even before someone came up with names for those things. I've been using Ansible for quite a long time, at least as far back as 2014, I believe. Back when I was doing OpenStack things, I was troubleshooting Ansible playbooks every day. I sought out a way to make my own life easier. I eventually came up with something that was called ARA. Somehow it became useful for other people, and I think that's amazing. I was previously in the Ansible community team with Red Hat, working with Gundalo and many fine humans over here. I probably use Ansible for too many things. Some years ago, I did a presentation here how we eventually built Ansible using Ansible, because, why not? Nowadays, I don't do open source full time or anything like that. But I'm still very enthusiastic about open source. I do it, between my own job and as a dad, and doing DevOps and DevOps. So, should I ask you to raise your hand? I'm mostly curious. Has anyone not used any of those big cloud models? So I see maybe 2, 3 hands. So, these big models, they're useful. They're available. You can use them to ask any kind of things, including Ansible, right? So big capable models online in the cloud, probably not free. If they are, maybe there's something about them that data and stuff. But in a professional context, you have to ask yourself the question about security, privacy, confidentiality. You're sending them to a third party up in the cloud. You might have a contract that says they won't train on your data, but things happen, and there's this kind of geopolitics thing going on here. Digital sovereignty being a theme. What about local models? I have a lot of smart devices at home. None of them connect to the cloud. They don't have access to the internet. I'd rather have local stuff for privacy, but also for convenience, and I don't have to pay a subscription for them every month. So some time ago, I acquired a framework desktop, a really great machine. We will go into some other details later. Really, what's interesting about this is that it's very small. It could fit in my backpack. At first, I wanted to bring it here. It would have been like a very cool stunt, I think. But then it would have meant carrying a computer for a couple of days and being stressed about whether it could get stolen or anything. So we'll settle for the best next thing, because I really wanted to do a live demo on the framework desktop to show really offline without any kind of internet. So I have I'll go through a live demo on this at home without internet. I'll save. I won't spoil you the surprise for later. But we'll get into that. So before we start, I want to get into a little bit about how you could run local models at home. If you have anything that looks like a gamer PC, you can probably run even modest models. If you have something like a framework desktop, you can run bigger models. You can have like a big Mac Studio with 512 gigs of memory. Then you can then run even bigger models, and there's people who cluster them together. But the point is, you can run these at home. So I want to get into like some of the vocabulary, how it works, and how you can try and do that at home. So runtimes. So there's different ways to run models, right? So probably what is the biggest project to run models is called llama.cpp, on which actually there's a lot of products that build on top of llama.cpp. Either they run it like out of the box, or they vendor their own version, or maybe slight forks. Purists in the domain will tell you should be running llama.cpp because that's like the upstream version of the thing. But LLM Studio and Ollama bring a lot of user experience and user convenience. They're easier to run. It's not very complicated. There's nothing to compile. It's just regular software. Ollama reminds me a lot of Docker in terms of user experience. You have a registry, you do kind of like Docker pull and Docker run. Well, it's like Ollama pull, Ollama run, and you can run a model. It's not very complicated. And LLM Studio, well, I'll show you because it'll be part of live demo. Then you have registries. Just kind of like you have Docker Hub, you need to host the models somewhere. So these models, they're files. Some are smaller, some are bigger. Some of the bigger models, to give you an idea, one of the bigger models that I'll show later, it's a 120 billion parameter model, and it's about 60 gigs. So, if you told me 20 years ago that I could have a 60 gigs file that would allow me to have something the equivalent of Google, Stack Overflow, Wikipedia, and all these things together at home, offline, I would have told you you're crazy, right? But here we are. In spite of all its flaws, I think there's some very interesting technology here, and so we'll get into that later. But anyway, Hugging Face is meant to be kind of like the GitHub of AI models. That's where OpenAI and Google, Microsoft, and so on and so forth publish their models. You can just download them, and somehow they make money. I don't know, but for now it's still alive. And then LLM Studio and Ollama also host their own models, and so you can get them from there as well. Hang on a sec. And then you have the models themselves. So there's a wide range of models trained on different data, with different size, different architecture, different performance, different. Some are more specialized in code. Some are more specialized in science, and so there's really a wide range of models. I'm going to be showing the 4 here because those are the ones that I use and test with. They're really quite competent at Ansible things. They know about Ansible. They also know about ARA somehow. And we'll go into some more details now. And then you have what I would call integrations. So it's not runtime, not models, not registries, but things that leverage models that you can use to do things, right? So a Home Assistant is one. I have a Home Assistant at home to automate some home stuff. It's not in the cloud. It's hosted in my OpenStack cloud that I have in my basement because why wouldn't have a cloud in my basement? A very popular project, it's called N8N. Allows you to do workflows, and it's quite powerful. So you could have, you could ask questions to a model in your workflow. There's a guy on YouTube that's like automated his own lab troubleshooting through N8N. And like N8N through a model will send him a message on Telegram, I need to restart this service, is this okay? And then you can click okay and it will approve, and then the model will launch the command. It's kind of scary, I don't, I've never, not yet, I'm not ready to give right access to production stuff to LLMs yet, but here we are. And then, this is very new, but another example was ClawBot, which was renamed Boltbot, which was renamed OpenClaw. And it gets really weird if you want to look into that, but it can hook up to a lot of your stuff, your email, your Discord, your Signal, and you can use it as a personal assistant, basically. It will really, it's kind of scary, but it's a thing, it's very popular, it's gone viral over the past week, and they've done a kind of Reddit-like site, it's called Moltbook, where the agents can speak between themselves. It gets really weird really fast, but AI, it's like slop at scale, basically. So what about local models? So the local models, even if it's not like expensive OpenAI, Claude stuff, they know about Ansible. I can ask them, explain like M5, why might a sysadmin be interested in using Ansible? Why is this question interesting? It's because it's able to reason, and draw an analogy, explaining to a kid or like a sysadmin why might they be interested in using Ansible. And it's not like, I think it's a pretty apt analogy. You have like 100 toys, and you need to do something with each of the toy. You're not going to do it manually. You can have a robot do it for you. You put a hat, I think is the hat, red car. Anyway, so the idea is that it's used to automate things at scale because you don't want to do it manually all the time, right? So these models, they know about Python and Jinja and YAML as well. It's not a very useful use case here, but I told the model, can you write a short and simple Python script that uses Jinja to render YAML? For the sake of exercise, I'm not sure I would do that, but hey, that's kind of what Ansible does, but the script works, and it knows about Jinja, it knows about Python, it knows about YAML, and then you have like all these coding assistants like Cursor and so on. So these models, they're able to do programming. They know about sysadmin stuff. They know about configuration management, and that's what where the magic happens. So I bring the question: can they troubleshoot playbooks? So the reason why I originally came up with ARA is because I was troubleshooting these playbooks all the time, and I wanted to make my own life easier. And I sought out to check, can they understand how a playbook runs and what might have gone wrong? So I did some testing. On purpose, GP Mance is not with us today. He doesn't enjoy the cows, but I kind of left the cows on purpose, right? So would the models be confused by the cows? And this is, so I thought I would redo this after the fact, but this is with the newer versions of Ansible, which are actually really good at telling you, where the thing failed. This is an improvement for 2.19, I believe. So it was pretty good, but I feel that it might have hinted the model like, oh, this is an Ansible playbook and this is an error. But anyway, I left the cows because I thought it would confuse the model. So I copy pasted that. I said, what's going on here? And then the playbook, the model actually understood what was going on. It wasn't confused by the cows. So it thought for a while, and then the playbook gathered facts successfully, but then it explicitly called the failed playbook module on line 8 to stop with execution mission. This is a failed. So, easy example, this is actually out of the integration test for ARA. So it's a failure on purpose. It didn't confuse the model, so it was able to tell. So what about something more complicated than just, a small playbook that fails on purpose? So recently, I've been working on the ARA collection. So there's an ARA collection for ARA. Unfortunately, it's been kind of neglected over the past couple of years. I don't have a huge use case myself for it, and I don't have a lot of time, between my job and other things. So, it's crazy the pace at which Python versions and Ansible versions and operating system versions come and go. So, things break when you don't take care of them. And so recently, I migrated ARA from GitHub to Codeberg, and I took this opportunity to fix up the collection, bring it to modern standards, and make it compatible with newer versions of Ansible. There's still some 2.19 things to fix, but I'm getting there. So what I did, I can open this up here. Oh, the link. Can I do it? Can I? It's not letting me. It's not a link. Okay, here we go. I'll copy paste it. Hang on a second. So this is in Forgeo Codeberg. Forgeo Action. It's it's kind of like GitHub Actions. It's like 95% compatible, maybe. And so I have CI jobs in the collection, and of course the CI jobs are written as Ansible playbooks because, you know, why not? I'm not going to be writing Bash. It's like I'm going to use Ansible, right? So the job, you know, it sets up, you know, a virtual environment and installs ARA on it, and then, you know, it does some things. And actually, so of course I use my OpenStack Cloud in my basement. So I spin up a VM, and then I try to deploy ARA on it with, you know, different database backends, different OS. It allows me to tell, you know, whether it works or not. You've probably all seen this before. You know, it's like, this is a little bit of verbosity. And, you know, I can scroll like this. Maybe I can do a Control F and hope that my browser does not crash. But, you know, you've seen this before. Oh, it failed here. Okay, hang on. There's some \ands here all over the place. Okay, there's some. Okay, all right. So what I would do is, so because these are Ansible playbooks, I record them in ARA because of course I do. So I have. Hang on. So I have. I'll go into the live demo. You can access this if you would like. It's available. It's open. It's there. So the Codeberg jobs, the playbooks that they run, they're recorded on the live demo, such that if I want to troubleshoot something, well, then I don't need to scroll through, you know, 20,000 lines of code. So I have labels here because there are labels in ARA, and these labels, you know, I use them for a number of things. I can identify the pull request. I can, you know, whatever labels I can think of. Here I'm going to look for the commit hash for that particular job. I see the failure here. I'm going to go and open that up. Right away, it brings me to the failure here. It filters out everything. It brings me to the obvious part. You know, the SQL migrations failed. But you know, I have other interesting things here. I can walk a little bit through. But I have, you know, all the information. Let me zoom in a little bit. I can even go in light mode. So there's the CI arguments for the playbook. You know, if there was a limit, if there was any other things. I have the versions of Ansible, or actually Ansible Core, the versions of ARA, the version of Python. I have all the files that were involved as part of the playbook, so I can open these up if I would like, you know, to see. You know, exactly what file ran as part of this playbook. So, you know, if I change the playbooks in 2 weeks, you know, I can still go back and see, you know, what was like 2 weeks ago, right? And then I have the details per host, and then I have, you know, the failure here. So I can open this up, and I can see the details of that particular task, how long it took, and so on. And then I can see, you know, something that is a bit more readable for humans. It makes it, you know, easier to understand and troubleshoot. And then I can see, you know, exactly where this task ran. I can click on that. It brings me directly to the line that failed. And, you know, it makes it easy to understand, you know, in the greater context of the playbook, you know, where this thing happened. So, you know, it turns out there was a PsycUp2G thing. Not going to go into too much details here because it's not super relevant, but the ARA server under the hood runs Django. ARA supports SQLite, MySQL, and PostgreSQL through Django. If you want to use PostgreSQL, you need the PsycUpG library. I thought I could update to PsycUpG3. PsycUpG3 is actually called PsycUpG. It's not the version 3 of PsycUpG2. Anyway, I got confused, you know, as it happens. So this is why it failed, and so, you know, it made it a little bit easier. What else can I show you here? So there's the host view as well. So I have the CI VM here, which gives you a little dashboard, a little overview. So when Ansible runs and you gather the facts, there's a lot of information in there, it turns out. So, you know, there's the server load, there's the OS, the kernel version, the Python version, and so on, the memory usage. So this is a snapshot in time, right? It's not real-time information, but it's information from exactly when the playbook ran. So, you know, maybe the playbook failed because the load was high, or you know, ran out of disk space. It could have been anything, some information there. And then there's all the host facts here. So I can search, I don't know, the family of the OS family fact, or the Linux fact, or whatever, right? So this is, I use this fact feature a lot because sometimes I want to see what the values look like so I can use them in my playbook later. Like just earlier this week, I was doing some Linux stuff, and I was curious what the values of the Linux fact looked like. So I just went to any playbook, and I was able to see, and then I was able to craft my condition when Linux is enabled, set it to permissive, because shouldn't do that, but sometimes you gotta do it. So that's kind of my workflow here. Let me go back to the slides. Where are my slides? They are here. So the question, back to the question: Could I ask a local model to troubleshoot this? Could it come to the same conclusion? Let's find out. So what I did is I copy pasted those 20,000 lines of console output that you would have in your terminal or in AWX or Tower, or sorry, automation platform. I still call it Tower. I'm sorry.
You're not the only one.
I'm not the only one. All right. So I copy pasted this into a text file, and I asked it, can you find out what's happening here? I didn't hit it or tell it anything, and kind of. I did not know what to expect really, but it is very accurate. It is able to tell, this playbook, it spins up a VM. I was mentioning that earlier. It installs some dependencies. It starts a PostgreSQL container. It deploys ARA using the ARA API role. It installs the database dependencies, and then it tries to run the SQL migrations. Where it blows up, it fails 3 times with this traceback. It finds out the error because that's in the console output, right? And then it continues and even suggests a fix. I mean, I didn't ask it to fix anything, but it went on and found the issue and proposed a plausible solution. So I think that was pretty cool. However, I can close this, I'm sorry. Because this was 20,000 lines of text, it took 318 seconds to parse the data because it's a lot of tokens. It needs to chew through all of that and then reason around, what was in there. So it took like 5 minutes. Yes?
But it was on the hollow tricks.
Yes, that was so all the numbers that you see, they're out of my framework desktop, yes. And this was using the GPT OSS 120B model. So a pretty big model, the open source model out of OpenAI. So yeah, ouch. Another thing is the number of tokens. 60,000 tokens. That's over 9,000. I'm at home, I'm not paying for the tokens.
That's great.
That's amazing, right? But it still, took 5 minutes because the 60,000 tokens. So if I sent this to a cloud, it might have been faster because, they have these big GPUs and data centers, right? But if you're paying by the token and you want to do this 100 times a day, it could get expensive, It's not money, but, you can do whatever you want. So can this be easier? Of course it can. So ARA records Ansible playbooks. It makes them easier to understand and troubleshoot. It is another recursive acronym with a focus on simplicity. So what does using ARA look like? I talked a lot about ARA. Should do a live demo. How do you get started? So you install Ansible, you install ARA. ARA needs to be installed wherever Ansible runs from. So if you're running out of virtual environment, you would install it inside the virtual environment. If you run it in AWX or automation platform, it would be inside the execution environment, probably. Then you enable the callback plugin to enable ARA. And then that's it, really. The rest you do as usual. You run the playbook as you would usually. That's like the thing. So, and then it works. You have a CLI, you can browse the results. You can, the CLI has some flags where you can output, by default it would print as pretty tables. And pretty tables, sometimes they're not very pretty, depending on the number of things that it wants to show. But you can use -f and then output the results as JSON or YAML. And then I know of people who have done scripting around the CLI, where they use the JSON and some fancy GQ, and it's there, it's available, and it works. And you can run the embedded web server. So the interesting thing about this is you can see the getting started instructions. Nowhere is it required to start a server. So by default, there's no service required. The callback has a default API client that's called offline. What it does under the hood is it spins up an ephemeral server, and then the callback sends the data to this ephemeral server. So you don't need like a systemd service. You can run one if you want, but you don't need to by default. So really, it's really easy and simple to get started. How it works. So you have whatever triggers an Ansible playbook: a human, Jenkins, GitLab, Rundeck, AWX. Your cat, I don't know. You run Ansible playbook, and then ARA provides a callback plugin. And then this callback plugin allows ARA to hook into all the events that occurs. So when a task starts, when a task fails, and so on and so forth. So it uses these hooks to send the data to the Django API server, which then saves it to a database. By default, it's SQLite. Works pretty well. As long as you don't have a lot of concurrent Ansible playbooks running at the same time. But the idea, of the default experience, you don't need to run a server. You don't need to run a Django server. You don't need to run a database server either, because it saves to SQLite by default, right? And then it continues like this until the playbook ends, and that's it. So in real time, as the playbook runs, it saves the data into a database. And then because the things are in a database, organized, it's easy to provide an API and a web interface on top of it, right? So it has an API. It's a Django REST framework API. It's an amazing project, really. I love it. It's magical, almost. This is available also in the live demo, and everywhere where you spin up the ARA server, the API is there. It's available. You can click through and use it if you'd like. You can. It's an API, so there's an API client also that you can use to make it a little bit easier to get and work with data. So, So, what if we gave access to the models to the API, right? So I asked myself this question in June, so like 7 months ago. There's this thing called MCP servers. I think when I looked at this 7 months ago, it might have been like 6 months before. Like MCP was still a very, very new thing back then. Like I'm not even sure if it's like 1 year old today, right? So it was still very, very new. And I had people ask me in the past, would it be possible for LLMs to query ARA? I didn't know back then. Eventually MCP emerged. Like there were like, I want to say predecessors to MCP, like function and tool calling and things like this. But I hadn't really had time to look into it until then. So I did this very little experiment. There's a link here. You can look at the demo that I did back then. It was pretty rudimentary, but I was able to ask a local model. Back then it was running Olama. I was able to ask a local model information about my playbooks, and it worked. But it wasn't quite the user experience that I was looking for. And so since then, MCP has grown, has matured, it's gotten better. I've also learned a lot about it. You know, when I looked at this, it was mostly for educational purposes. So I wanted to learn what was MCP like, how it worked, and what was the possibilities, right? So how does MCP work? So I have this little chart here. So we have the local models, the local runtimes, I'm sorry, that I mentioned earlier when we began. There's the registries, there's the models, right? You have the cloud models as well, because Cloud allows MCP servers as well. But you know, on the premise of the talk, I don't want to use Cloud, I want to use the local stuff. So these runtimes, they talk to MCP. MCP is a server that gets started. There's some, I would describe it like as an API for APIs. Like it tells the models, it gives tools to the models so the models know how to query things. And there's MCP for a wide range of things nowadays. I think recently there was an MCP server released for AAP as well. So you know, it's an interesting piece of standard that didn't exist, you know, even a year ago. And then it's this MCP server that has the functions that knows how to query the ARA API to get stuff. And then the ARA API takes care of querying the database, you know, and returning whatever the MCP is querying for. So you need, when you use MCP server, you configure them in whatever tool you use. In LM Studio, it looks like this. I think it roughly looks like this in other tools as well, but you know, your mileage may vary. But the general idea is you tell it how to run, how to start the MCP server. Here it's in Python. ARA is in Python. I'm familiar with Python, you know, but it could be in Golang and you know, whatever. It uses the MCP Python library, and then I tell it, I give an environment variable what server I want it to query. Here it's the demo, yeah. So once, this is a screenshot from LM Studio, which we'll get to in a moment. But this is the list of tools that the MCP server provides. So there's get playbook, list playbooks, get task, list task, and so on. And then there are, like, I want to call them wrapper methods. So there's troubleshoot playbook. So there's a particular function that the model will know to use when I'm interested in troubleshooting a playbook. And this troubleshoot playbook method will use like get playbook and maybe some other things as well. Same thing for a host. And then there's another one which is interesting, is analyze performance. So because ARA records everything about the playbooks, it knows about the metrics. So how long each task took, how long each playbook took. And so I was curious to find out if models would be able to tell, you know, hey, you're losing a lot of time here. You could optimize the performance of your playbook if you did so and so. So we can find this out. So I want to go into the live demo. I don't have my framework desktop here. So I will jump out of here. And I will go to a KVM IP that I have hooked up at home. So, you know, I said it was without internet, but I have to connect home to internet. But what you can see here is that I have no Wi-Fi. I have no network connectivity. You know, if config here, there's no internet, you know, I'm not cheating. There's no internet here. I'm offline. Other than the fact that I have a KVM IP hooked up to my thing, I don't have any kind of internet. Oh, no. Sorry. So yeah, I get confused sometimes because I hit the hotkey and you know I think it's going through the KVM IP, but it's on my laptop, so I have to be careful here. All right, so let's try that again. So what do I have here? I have an ARA server running. It's running GUnicorn. It could run whatever WGI runtime that you prefer. Here it's GUnicorn. So I have ARA checked out with the repository in which the MCP server is in. I install Unicorn on it, and it's here. I run it, and it available on port 8000. So it's available on localhost. If I go on the Firefox here, on my framework desktop, you can see I'm on localhost here. I'm not going out to the internet. What this means is ARA has no external dependencies, right? So it doesn't there's some websites that fetch JavaScript or CSS across the cloud and some CDNs. There's nothing like that here. Everything is vendored, completely, self-hosted and offline. So for the sake of the demo, what I did is I took the database from demo.records.ansible.org. It's a MySQL database. I dumped it, downloaded it, imported it here. So we have the same database, and I have the same playbook that I showed you earlier with the PostgreSQL issue, right? So this is the one, in fact. Yes, it is. So I see it here. It's the same playbook that we just looked at. But this is, offline. Now, I have, before we go to LM Studio, I have two things here. So I have, this is a software called, what's it called? I forget, LACT. So this is real-time view of the GPU of the framework desktop. I will go a little bit into the details about the hardware of the framework desktop just after we're done. But the general idea here is that, there's not much going on here. And I have a BTOP running here, which gives me a real-time view of the CPU, RAM, and GPU usage. So nothing going on here, very special. I'm going to go in LM Studio. In LM Studio, can I zoom this? Yes. It's Electron. It's awful, but because it's Electron, I can just, So I have, what I showed you earlier, but the API server is the one running locally. It's not the live demo because, well, we don't have internet. I have the MCP server here enabled. I'm going to open a new chat window. I need to load a model. So I have a bunch of models here. Llama, GLM, DevStrol, Mistral, and so on. I'm going to use GPT OSS 120B. You see, I told you it was 60 gigs. I was pretty close. It's 59. So I can define the maximum context length. So context in LLMs, it's like the window in which they remember stuff, kind of, right? So if it exceeds the context window, things go wrong. So that's what it means is because you're not running in a big GPU in the cloud with like nearly infinite memory, you need to be mindful of the length of the context that you put in. So remember earlier when I was telling you about 60,000 tokens? That's a lot. Like I'm at 100,000 tokens here. The maximum I could support is 130,000 tokens. So and then if you follow up with a question, all of the conversation until then is reparsed, right? So it's not linear. It's like exponential, I guess. So I'm going to go ahead and load this model. It's not going to take very long, maybe a few seconds. I'm going to go in the chat here. I'm going to go here. This is the playbook that failed, right? So I'm going to take this. I'm doing Control-C now, but is it doing Control-C here or there? I don't know. I do it like this. So the model is loaded. It's ready. I can ask it anything. I will ask it, can you find out what went wrong with this playbook? Right. Now it's going to take, how long did it take earlier? 5 minutes. So it's thinking, it's troubleshooting, it's querying ARA. We're less than 30 seconds. It's already replying me stuff. Let's see. I'm unable to pull the details for the playbook right now. Why is that? So this is why you want an MCP server to work, because otherwise it hallucinates stuff. So let's see if we can get this working. Hang on. So I'm gonna go. All right. So Unicorn is running. I can query it. I suppose I was running through the web interface. Yeah. Okay. All right. Let's try this again. Oops. Wrong Alt tab. Wrong computer. Okay, let's look at the MCP configuration again. Yes, be mindful, MCPs can be dangerous. Let's not see this again. So I forgot the 8000. I'm sorry about that. Okay, let's try this again. I'm gonna trash this conversation because let's copy paste it though. The thing. Can I copy paste that? Yes, I can. Am I gonna be pasting on the thing? All right, here. Okay, let's try this again. All right, it's calling troubleshoot playbook. You can expand that and see, what it is using to query and what it's getting back as in terms of information. So the MCP, it's going. I'll come back to it later. Oh, please let me scroll. So the MCP server really it returns text. It queries ARA and gets some JSON stuff back, right? Because the API is REST API in JSON. But what the MCP server returns back to the model is just text. Because, well, LLMs are good at, parsing text and understanding text. You can do JSON as well, but, so this is what it returns. How are we doing on time? Yeah, we're good? Okay, cool. So it thought for a moment. I'm going to just collapse this. Playbook, this one, what went wrong? So the playbook name was PostgreSQL. The status was failure. This is the task that failed. This is the host that failed. What kind of OS and Python version that was. This is the scroll is kind of weird. Okay, but it found this out very very quickly. Why it failed? Because it doesn't have the Python PostgreSQL driver installed. It's like G2. So it comes to the same conclusion as sending in the 20,000 lines of text. And then it goes on to suggest a fix. Something I want to mention here. Earlier I showed you that ARA also saves the files to the playbook. And so the MCP server is able to query those files and use them in the context. So it's able really to get the snippet, the part of the snippet that failed, and suggest a less hallucinated solution, basically, right? Something that you don't have with just the console output of the Ansible playbook. So let's continue here. It provides some troubleshooting steps. Maybe there's something going on with the virtual environment, and then after installing the driver, try the playbook again, and then optional next steps. It suggests some other things. So the thing that was really interesting to me here, not Ansible, but these local models, like I told you before, they know about sysadmin stuff. They know about SRE stuff. They know about applications. They know about configuration management. They know about Ansible. So when I wrote this MCP server, I didn't need to do anything special other than just allow it to hook it up to the ARA API. And then the model is able to use this context and understand what went wrong, and then be pretty accurate about what it's suggesting, right? I think that's what makes it very amazing. And how long did this take? Can I see? Where is it? I cannot see how long. Oh well, it took a few seconds, right? Like less than 30 seconds, so not 5 minutes. And more importantly, it didn't use 60,000 tokens. It used 1,600, right? So because it's querying the ARA API, which has, it's able to query, give me the results that failed for this playbook, and then it gets the result directly, which is very short, compared to the entire length of the playbook. So I think that's pretty cool. I have another use case. Troubleshoot host is, it works kind of the same, so I don't think we need to go through it. But there's this analyze performance one that I think is interesting to walk through. So I'll go back here. I'll search for some playbooks that I know take a while to run. OpenStack takes a while to deploy, So So these are some playbooks that go back in 2023. Because I used to be involved in the OpenStack community, I still kind of am, but these are playbooks that ran to test a deployment of Ansible. So in OpenStack, when you send a patch to Gerrit, what they use for version for code review, there will be a bunch of CI jobs that run, and then there's some Ansible there's some OpenStack projects that use Ansible, and so they can use ARA. And so I have some of those playbooks recorded here. So these playbooks, they take an hour or something like this. So let's find out. I'm going to take this playbook. I'm not going to do Control-C because I'm not sure if that's going to work. And so if I go, scroll. Sorry, I'm going to use the. I can sort the tasks by duration here. I can do the same over the API, but you see, I get the tasks that took the longest here because I sorted by duration. So this one took 8 minutes, and so on and so forth. There's some Tempest thing. Tempest is the framework in OpenStack that runs a bunch of integration tests. So what I want to do is I want to take this playbook. I opened up a new chat here. Can you find out if there are any performance improvements opportunities. Let's try and not do typos to confuse it. I don't know. It will probably not mind for typos, really, in this playbook. All right. So I will ask this, but before I go, what the MCP server will do under the hood is it will not only query for this particular playbook. It will query, I believe, the 5 last playbook that ran for this particular task. Because we're looking at performance, we want like maybe more of a sample, look at different playbooks. There might be anomalies for this particular playbook that did not occur in other playbooks, and the models will be able to tell. So it's going to go and query. Something that I didn't show is, I have, so here the model, the MCP server is doing these queries, going through the results for each of those playbooks. And here we go. Performance improvements opportunities for this playbook. So it understands, what the playbook was about. It found the top, the slowest task. I was talking about Tempest. It knows what Tempest is because, of course, it knows. It knows about OpenStack and all of those other things as well. It found out that setting up the virtual environments is kind of slow. The package installations was also kind of slow. The pip installations were kind of slow. There was some command and shell usage that was kind of slow. And then, there's only 8 forks going. Maybe you could increase the amount of forks that Ansible uses so it could run faster. There's a lot of file transfers going on. There's no, I didn't write any particular code that was able to, that would parse these things. The models, they just know, right? So this is where the magic happens. And then it provides some quick wins. You could increase the number of forks that would be faster, maybe 20 to 30%. You could cache the Python wheels, so the virtual environments could be installed faster. If there's a lot of different package tasks, maybe you can do just one. So you're doing dependency resolution just once, and it ends up being faster. Maybe you can run Tempest in the background, and so on and so forth. So I think that's pretty cool. That's what I had in terms of demo. So let's go back. Oh yeah, let's look at BTOP. Oh, I mean it's gone. It was too fast. Maybe I have it here still. Okay, so you can see when I query the models, the GPU gets very busy, of course. So let's talk a little bit about the hardware of the framework desktop. Nope, not here. Here. Yeah. So this is a Ryzen AI Max plus 395. It's quite the mouthful. Really, it's not so much about the framework desktop than this particular AMD chip. So the code name for it is Trix Halo. You might have heard about it. What's particularly interesting is I'm running Fedora out of the box here. When I got the framework desktop, a couple months ago, I had to run Rawhide, which is the rolling release of Fedora. It was kind of bleeding edge. You're running with AI. There's so much new stuff. But right now it's running Fedora 33, and it runs just out of the box just fine. The very interesting part about it, so I have 128 gigs of RAM, and kind of like MacBooks with Mac Silicon, Apple Silicon, I can choose how much RAM I dedicate to the GPU. So I have 128 gigs of RAM, and it's in the BIOS, or UEFI, I don't know what you call it nowadays, but I told it, give 96 gigs of VRAM to the GPU. That's a lot of VRAM. Like the biggest consumer CPU on the market right now is a NVIDIA 5090. It has 32 gigs of VRAM. Of course, it's more performant. It has better bandwidth, better latency. It's like a big card. It's also very expensive. So for the price of a 5090, I got this entire computer, really. So it's about. I'm from Canada. I don't know what the currency goes, but in all transparency, this firmware desktop with the NVMe and the RAM and everything, it costs about $3,500 Canadian or $4,000 Canadian, with taxes and everything. That's the price. That's about the price of a 5090 right now, and I'm not finished. So the 5090, you pay this price and you only have the card. You don't have the computer yet, right? I'm not finished. You need it will suck up 500 to 600 watts of power to the point where the connectors, the PSU connectors to the card will melt, and it's a literal fire hazard. You could put your house could burn down because of your GPU. This entire computer, the firmware desktop, it barely goes beyond 200 watts. The CPU, the GPU, the RAM, everything, the fan, it's super quiet. It fits in my backpack. It has a Noctua fan. There's an option to have a Noctua fan. It's really quiet. And the fan will only ever turn on if I query the model. Otherwise, it's you can't hear it. So, within the footprint of something that fits in my backpack, not much larger than a banana, fits within 200 watts, I think, that's pretty awesome. So going back to the slides here, and we can almost wrap up. So what are the next steps? I told you about this. I'm really excited about it. It's not yet open source or anything. I want to wrap it up, clean things up. I had just want to make sure it's pretty fine to open source. It won't be part of ARA itself. It will be in /contrib, where there's other things like container images for ARA and things like that. It's entirely optional. You don't need to use it if you don't want to, right? But it'll be there for those that want to use it. I was showing you this example for my CI jobs in ARA, because one of the use cases I have is I would like to integrate it right into my CI pipeline. So when there's a failure, I want to be able to I want to use this failure, hook it up to a model, so the model could work through what failed, and then send a comment to the PR with details about what failed and what might be the fix. Now I've talked about MCP. There's this new shiny thing that also didn't exist even 6 months ago, called skills. So they're markdown files that tells models how to use and do things. So that might be interesting. And then there might be other use cases. We've only talked about troubleshooting and performance, but I'm sure there's a lot of stuff that you can do once you have all these Ansible stuff in a database. That's all the time I had for you. I don't know if you have time for questions. No time for questions. Okay. Well, it's okay. I'm not sad or anything. But I'll be around. I am flying back to Canada tomorrow morning. So if you want to chat, I'll go out here. And there's some stickers here. I was really happy to talk to you guys.